This morning in geometry you are going to be learning about rotations. We talked a little bit about that before when we just kind of did an overview of all the transformations. So a rotation is a transformation in which a figure is turned about a fixed point. The fixed point is the center of rotation. So if we're looking right here, that P is the center of rotation. Also over here, that P is the center of rotation. Rays drawn from the center of rotation to a point and its image from an angle called the angle of rotation. So your angle of rotation is going to be how far it goes from the original image to the next image, so the pre-image to the image. A rotation about a point P through x degrees, so depending on how many degrees you're moving it, is a transformation that maps every point Q, so we have Q, in the plane to a point Q prime. So you're going from this one right here to this one, Q prime, so that the following properties are true. So when you do a rotation, these need to apply, 1 and 2. If Q is not point P, so if you don't have a Q right here on P, then QP, so going from here to here, is going to be congruent to Q prime P, so it doesn't change at all. And the measurement of QP, Q prime is going to be, so QP, Q prime, x degrees. So we'll find out what those degrees are when they tell us how many degrees to move it by. If Q is point P, so in this example right here, then Q, no, that's just showing a different degree change. If Q is point P, so let me change the example, and let's say you have Q right on P, then Q is congruent to Q prime, so they would both be equal as well. Okay, so one example is just the rotation of 60 degrees, and another example is the rotation of 40 degrees. This one's going clockwise, so following the hands of a clock, and this one's going counterclockwise, so going opposite. You can tell that the rotations, if they're smaller in degrees, they're going to be closer together. Rotation theory is that rotation is just an isometry, and that's a reminder of that is it doesn't change shape or angles or parallel lines or anything like that. Okay, this gives you a step-by-step list of how to do rotating a figure. So use the following steps to draw the image of triangle ABC after a 120 degree clockwise rotation about point P. So we have our original ABC. It says to draw a segment connecting the vertex A, so we have A there, and the center of rotation P. So you just put a P there. And then you use a protractor to measure that 120 degrees. So you line it up on the line, and then you go to your 120 degrees, and then you draw a ray from that 120 degrees going out. Place the point of the compass at P. So you put your point in at P and draw an arc from A to locate A prime. So you're going here and you're locating that A prime on the 120 degrees. And then you just repeat steps 1 through 3 for each vertex using that P as your point of rotation, and you connect the vertices to form the image. Yes, there's a theorem that goes with these. So theorem 7.3, if lines K and M intersect, so we have K and M right here, so I'll circle those, and they're intersecting right here at P, then a reflection in K, so we have K here, followed by a reflection in M, is a rotation about point P. So if you look, so I have this original pre-image, then I rotate, or I reflect it over line K to get A prime, B prime, and then I also reflect it over line M. I'm going to have B double prime and A double prime. This actually is going to be a rotation around point P. The angle of rotation is 2x, where x degrees is the measure of the acute or right angle formed by K and M. So we have K and M, and the measurement is right here of that x degrees. And here's the formula that you would use for that. So you have the measurement of angle BPB double prime equals 2x degrees. So if we have B, P, and then B double prime, we're measuring from here, the original, all the way to that B double prime. And that'll give us our degrees that we actually rotated the image. A figure in the plane has rotational symmetry if the figure can be mapped onto itself by a rotation of 180 or less. For instance, a square has rotational symmetry because it maps onto itself by a rotation of 90. So here's our pre-image. If we do a rotation about a point at 45 degrees, it's going to look like this. And we don't quite have that original image, that pre-image. Then we rotate it 90 degrees again, and it's exactly like the image over there. So that is called rotational symmetry if it can do that. The only problem with this is you can't always do that. So you have to do it in less than 90 degrees or less, in order to say it has rotational symmetry. And that's it for today. I miss you guys. I'll have an assignment that goes with this. See ya.